Good evening. So I was asked about this question, question 6. This is on pure paper 2 in set 1 in the brown paper envelope questions. It may be one that you've looked at. I'm going to go through a solution. When I first looked at this, I thought this looked like a rate of change question, but actually it's just an algebra question. So we're talking about gas stored in cylindrical tanks. So I guess the key fact is that the volume of a cylinder is pi r squared, the area of the base, times the height. And the other thing is that we're told that in this particular case, volume is inversely proportional to pressure, which means that V is equal to some constant times 1 over P, or we can write that as V equals K over P. K is a constant, so this is volume, this is pressure. So let's talk about the before situation where the gas is stored originally. So this is the before situation. So the volume of gas is pi r squared and the radius is 2. So that's pi times 2 squared, so that's 4 pi h. And I'm going to call that sort of V0, the original volume. I also know that V0 will be some constant over the pressure originally. And so if I sort of combine those two formula, I get that. And I'm going to do the switcheroo to say that that is true. Okay, now you may not immediately understand why I've rearranged it like that. Bear with me. Okay, let's now look at the after situation. So we know that after the gas is transferred into a cylindrical tank with the same height, so we're going to have the same h, but we don't know the radius. So the volume after is going to be pi r squared h. We now don't know r squared. The volume will still be equal to some constant, and the relationship will still be the same, so the constant will be the same over the pressure. But we're told that the pressure in the new tank is 84% less than the pressure in the old tank. So if you want to reduce something by 84%, I did this wrong first time. I did 0.84, but of course, no, that's not. If it's reduced by 84%, it's actually 16% of what you started with. So this pressure here, the new pressure, is actually 16% of the old pressure. And so I'm going to combine those two equations. And then I'm going to rearrange it so it says P0 equals. So I've got a formula for the pressure in the original cylinder where I knew the radius was 2. And I've now got a formula for the same pressure using information for the new cylinder. The pressure in the new cylinder was 16% of the pressure in the original cylinder. So I've got two formulas for P0, so I can make one equal to the other. And now I can start cancelling. We know that I can divide both sides by k. Can divide both sides by pi, and divide both sides by h. H isn't 0, so I can divide both sides by h. So I'm left with 1/4, and don't forget we want to know the radius of the new cylinder. So it's r that we're trying to find. So 1/4 is equal to 1 over 0.16 r squared. Running out of space, so hopefully you can see what I'm going to do. I'm going to multiply both sides by r squared and multiply both sides by 4. And r is going to be the square root of that. Which comes out as 5. Which is the answer. Tricky question. Tricky question. I have to say, having gone through a few of the brown paper envelope papers now, which of course I hadn't done before I bought them, there's some really good questions, but there's some weird ones like that. There's also the really weird one with the r cos theta about the two boats travelling in opposite directions. I'm tempted to shift my focus to the 2020 papers. Brown paper envelope, still great practice, but I think now I've given you a genuine set of papers, I might focus on those first. But by all means, keep asking about questions like this. The second part is another algebra question, which I invite you to have a go at, but hopefully that has explained that, albeit rather weird question. Take care.